All right, so on the previous example, we used really two steps to differentiate each function. First, we applied the normal power rule. We brought our power down in front, and then we kept what's inside the parentheses there, subtracted one. And then after that, we had to take the derivative of what was inside the parentheses. So that was our kind of our du part. So now as you gain experience with our power rule, what you want to do is you want to combine these two steps all into one, kind of like what I was doing. I wasn't completely following it, but it's going to be this kind of same thing. And so if we look at this one, what we're going to do is we're going to take our power rule down. We're going to take 4 times this to the 4 minus 1 is 3. And then we have to remember always to take the derivative of this. And so that's going to be that 4 at the 5 times x to the fourth. We have to bring that 5 down and do that. And so this is kind of that derivative of the inside piece. We did the power rule out here to get this piece, and so that's how it would work. Some people, what they're going to do is they're going to do that power rule, boom, 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 and they're going to get this, but they forget to multiply by that du dx, which is that 5x to the fourth. And so you have to always remember to do that, because if you don't, you're going to end up with the wrong derivative, and it's not going to have the right answer. And so always remember you have to, do the power rule and then take the derivative of what's inside of there. All right. So if we refer to f and g in the composite function, f of g of x as the exterior function and the interior function respectively. Okay, so this is exterior, this is interior. The derivative of the composite of two functions is the derivative of the exterior evaluated at the interior times the derivative of the interior. Okay, so this chain rule is expressed more compactly in theorem 2 here, and you'll see in a second, with the notation chosen to aid again in memorization for E for exterior and I for interior. Again, this book's really nice about that. They kind of change it up as far as how it's done, but they make it so it's a little easier to remember. So if we have the chain rule is if we have some function m of x and it's the exterior function, and then we have an interior function, so E of I of x, it's a composite function. Then what we can find is the derivative is E prime, or the derivative of E times the I of x, and then I prime of x, okay? So again, we have to have the derivative of both of those have to exist. So equivalently, what we can do is we can say, well, let's let y equal E of u equal I of x, and then what we can do is we can take the derivative of this with respect to u times the derivative of this with respect to x, and that would get us the answer as well. And now here again, dy du and du dx have to exist. So that's kind of a couple of ways to think of that, about that. We're going to take the derivative of the exterior function and then times the derivative of the interior function. And so one way to look at it is this, one way to look at it is this notation here. All right, so let's look at here. We have, it looks like 3 more functions, and they're composite functions. And so it says find the derivative m prime of x of the composite function m of x. All right, so for A, what do we have? All right, so if we do this, again, we're going to take the outside function and we have the inside function. So this is kind of an inside function. The outside function would be the power rule. And so we're going to have a minus 5 times, then we'll have a 2x to the third plus 4. Subtract 1 from here, so that's going to be a minus 6. Now we have to take that times the derivative of this inside, so that's going to be a 6x, and that's going to be a 2, okay? Now, we could simplify this because this negative 6 probably want it to be a positive, and so, and this is our m prime of x, so maybe let's just keep going across and simplify as we go. So it's a minus 5 times 6, so it's going to be a minus 30x squared over, and we have now a 2x cubed plus 4 all to the positive power of 6. So we can have this, or if we wanted to, we could say it's also a minus 30x squared times a 2x cubed plus 4 to the negative 6. So all 3 of those are going to give us correct answers. Probably these latter 2 are going to be more correct because we've actually multiplied that 5 and 6 together and got the minus 30. And so I would say one of those 2. This one is more in lines with what we've been doing in class, hopefully, with the positive exponent here at the end. And so that would be probably the one I would go with, but this one, it would work as well because it starts as a negative here, so why not end as a negative as well? All right, probably too much there, but that's okay. All right, so the next one here, what we have is we're going to again find m prime of x. And that's going to be what? Well, again, we're going to have inside functions and we're going to have outside functions. So this is what I'm going to call my inside function. And the e to that is going to be my outside function. So if I do that, e to the x, if we call that, well, the derivative of that is what? Well, that's just going to be e to that x power. So that's going to be e to the 3x to the fourth plus 6. But now I have to multiply that by the derivative of what's in that inside function. So that's going to be what? Well, derivative, that's going to be a 12x to the third. Okay. All right, so now what does that do? Well, we could simplify that in a little different manner. I would say let's put this out in front, so that would give us a 12x to the third e to the 3x to the fourth plus 6, and that would then be my actual, derivative of the e to the 3 to the x to the fourth plus 6, okay? A lot of exponents here, but that's how I do that one. Same thing is going to be here. We have an inside function and we have our outside function. All right. So let's do that. So C, again, it's m prime of x is going to be what? Well, our outside function, really, if we think about it, that's just ln of x. The derivative of that is going to be 1 over x, but our x in this case is that. So it's going to be 1 over x squared plus 9x plus 4. Then we have to multiply that by the derivative of what's inside here. So it's going to be what? A 2x plus 9. And so simplifying that, the only thing we can do is we can say, well, that's 2x plus 9 over x squared plus 9x plus 4. That doesn't look like a very good 4 there, but we'll put a 4 there again. All right. So that is how we would get the derivative of that one. Again, we have to think about the inside function and the outside function. Outside function, ln of x, so the derivative, that's 1 over x, but we have to keep that as what's in here, so that would go back here, hence this. And then the derivative of this is just the 2x plus 9, and therefore ending up with this as our answer. All right, so let's stop there and we'll come back for more.